expand and simplify, so we act just like we would with algebra. For some of us, we remember from last year the word FOIL, which means you multiply your first ones, your outside ones, your inside ones, and your last ones. So when we're multiplying our first ones here, which is 4 root 2 times 3 root 2 plus 2 root 5 minus root 5. This would be our first ones. This would be our outside ones. These would be our inside ones. And these would be our last ones. Now when we're multiplying, how do we multiply 4 root 2 times 3 root 2? We multiply the numbers and we multiply the radicals. So when I do 4 times 3, I'm going to get 12. And when I do root 2 times root 2, I'm going to get root 4. We're going to simplify this later, but we're going to start. We multiply our numbers. We multiply our radicals. For the outside ones, when I have 4 root 2 times a negative root 5, multiply the numbers. And you imagine there's a 1 here. So 4 times a negative 1 will be negative 4. Root 2 times root 5 will be root 10. Inside here, we're going to get plus 6, because 2 times 3 is 6. Root 5 times root 10 is root 10. And finally, plus 2 times negative 1 will be negative 2 root 25. Now, the question says to expand. In mathematics, the word expand means you want to have no brackets in the end. So we had brackets. That's why we distributed everything here. That got rid of our brackets. And simplify, well, simplify means combine like terms. For radicals, do you remember so far what simplify means for radicals? It means write it as a mixed radical and combine like radicals. So we have to see here, do we have any radicals that can be simplified? Do we know the square root of 4? It's 2. So this becomes 12 times 2, so this will be 24. Can we simplify root 10 at all? Do one of our perfect squares divide 10 nicely? No. 5 divides it nicely, but it's not one of our perfect squares. So we'd just be checking 4 and 9, but neither of them come out nicely. So those ones can't be simplified, but you can see that the middle two are like radicals. Negative 4 plus 6 will leave us with plus 2 root 10. And then square root of 25 is 5, so negative 2 times 5 is negative 10. Are we done, or is there something else we can still combine? The 24 and the minus 10 will just leave us with 14. So we're simplified completely here. We've expanded. We have no brackets left. We've combined all of our like terms. We have our radical in simplest form. So we are done. For part B, again, we're going to multiply out like this. Oh, part B is a fun one. You'll find out in a second. It's going to have a nice answer for this one. First of all, 4 root 2 times 4 root 2. Can you see that that's going to be 16 times root 4? The outside ones, we're going to get negative 8 root 6. The inside one, we're going to get plus 8 root 6. And the last ones, we're going to get negative 4. And root 3 times root 3 will be root 9. Can you see that these two are going to cancel out? Negative 8 root 6 plus 8 root 6. They're like terms, and they'll end up with nothing. And 16 times root 4 is just going to be 16 times 2, which is 32. And 4 root 9 is the same as 4 times 3, which is 12. And the answer is just 20. That's why it's such a nice one. We'll find out that any time, and this happened when we did our examples at the beginning. At the very beginning here, when I said, here the answer is 5. Here the answer is negative 5. I would call these nice answers. They look pretty, right? I don't know where radicals got the bad rap, but when you get an answer that looks like 11 minus 4 root 6, people say, oh, that answer doesn't look nice. It's like, ugh. But those ones look nice. So how do we get nice answers? Some patterns we start to look for. Do you see that the numbers here and here are same as there and there? Same thing happened with this root 3, root 3, root 8, root 8. Same thing with the one that we just did. This is the same, this is the same. This is the same, this is the same. What's the only thing different? One is positive, one is negative. Okay? They have a name for this. When you have 4 root 2 plus 2 root 3, and you write the same thing with a negative, in math we call that a conjugate. And every time you multiply by a conjugate with radicals, the radicals will disappear. That's going to come up very important for example 4 today. Okay, the questions you can do for practice after the first one are 3, 4, 5, and 7.